had discussion on solving the quadratic equation. Then we discussed the linear equations in two variables. And since to solve linear equations in two variables, we required two equations. So that was why we also called it solving linear equations, solving simultaneous linear equations. Now we'll be taking a look at how to solve linear equation in three variables. Again, to be able to solve a linear equation in three variables, you need to have three equations. So we can also term this topic can also said to be simultaneous equations in three variables. So this is how you can state this particular topic also. Simultaneous because three equations side by side are given, then only you would be able to solve for three variables. We had talked about this particular rule that the number of equations should be equal to the number of variables, at least equal to the number of variables, then only you can solve the equations. So naturally, to be able to solve linear equation three variables, you need to have three equations, and these equations, since would come side by side, they would be called simultaneous equations and in three variables. Now let us have a look. Now this is equation 1, this is equation 2, and this is equation 3, and now we have to basically find out the value of x, y, z. Since the highest power of any of the term in these equations is 1, so this is basically a linear equation. And apart from that, since x, y, and z are three unknowns, so basically this is a linear equation three variables. Since all the three equations are there, see, they have been given side by side. That is why this can also be called simultaneous equations in three variables, right? Now we are moving on to how to go about solving these kind of equations. So first thing is, what you have to do basically is, it is very simple. You have to eliminate any one variable from all the three equations. Let's take an example. If you somehow are able to eliminate y from all the three equations, the first, second and third, what will happen? The remaining equation would be, all the three remaining equations would have only two unknowns. We have eliminated y, so what will be left is x and z in all the three equations. You can now make use of any two equation to find out the value of x and z, because you know how to solve linear equations in two variables that we have discussed in the last two sessions that we had. Is this fine? So you only have to do, what you only have to do is basically eliminate one of the variables. So either eliminate x or y or z, whatever is the most convenient to you, and whatever is the most comfortable. Depending on that, you have to eliminate one of the three variables. So you may eliminate x, you may eliminate y, you may eliminate z, and once you do that, if you are able to eliminate any one variable from all the three equations, then you would be left with only two variables, and you know how to solve linear equations in two variables. Is this fine? So this is how we are going to go about it. So now there are some tips on which particular variable would be the easiest for you to eliminate. So the variable that is missing in one of the equations. If a particular variable is missing in one of the equations, so for example, if one of the equation is only in x and y, which means z is missing, then you try and eliminate the z variable from all the three equations. So this is just some kind of a hint to you as to which particular variable you should choose to eliminate. Now variable with 1 as coefficient, those variables in which the coefficient is 1, they are easier to eliminate. We'll have a look how. We'll take up an example and we'll understand how. For example, have a look at this x here. This is easier to eliminate, only 1x, or maybe the z here, the coefficient here again is 1. So they are easier to eliminate, and you should first of all try and eliminate these kind of variables from all the three equations. And variables which appears positive in one and negative in the other equation. For example, if you look at z here is positive, here it is negative, so it is easier for you to eliminate z. How do you do that? Let's say in first equation we have plus z, in the second equation we have minus z. This here is minus 3z, but suppose it is minus z. Then how do you eliminate z? You simply add up both the equation. So plus z minus z would add up to become 0. Is this fine? And that is why this is being said positive in one and negative in the other equation. Is this fine? So go for these kind of variables. So these are just hints. You may decide to eliminate any of the variable, but if you go by these tips, you probably would be going for eliminating that particular variable which would be the easiest for you and the most convenient for you. So that is why these tips have been given. Fine. Now once you have done that, what will you do? I have already said, once you eliminate one of the variable, then you are left with the two remaining variables, and you are also left with 2 or 3 equations. Then you can use those equations to find out the value of the remaining 2 variables. And once you find out the value of the remaining 2 variables, then you can use those values to find out the value of the third variable which you had eliminated in the first place. Is this fine? We'll take up a question so that you are able to understand this better. So solving linear equation in 3 variables. So I've taken up the same question. So now here we are going to solve linear equations in 3 variables. Which one according to you is going to be the easiest for you to eliminate? According to the tips there, one option could be x because the coefficient is 1 here. It could also be z because the coefficient is also 1 here, as well as we have a plus z here and a minus z here, minus 3z and plus z, which mean we can do something so that the z and z get cancelled out. So let us start by eliminating z. So in this particular method, in the first solution that we are going to discuss, we are going to eliminate z. Fine. So how do we eliminate z? Now have a good look at how to eliminate z. Multiply equation 1 by 3. So this has to be multiplied by 3, right, to get equation 4. So when you multiply the whole equation by 3, you will get another equation and we will term it as equation 4. So this is what we have done, and I have told you that you have to eliminate from both the sides. So you basically have to eliminate from both the sides you have to basically perform the same function on both the sides of the equal sign, which means the left hand side as well as the right hand side, the functions that you perform should be same. So what I've done is basically I've multiplied the whole equation, not only the left hand side but the right hand side. That is why this bracket is shown outside. So basically now when you multiply it, this becomes like this: 12x plus 24y plus 3z. On the right hand side also multiplied by 3, it will become 6. So this is how equation 1 is now transformed, and we are calling this equation 4. Now you have to add equation. Now have a look at this plus 3z here. If I add this up with this minus 3z, what will happen? Plus 3z and minus 3z, they will cancel out. Plus 3z minus 3z will become 0. So we'll be left with x and y. So what I'm doing is, this equation, now I am adding to this equation, right? And the result would be known as equation 5. So we have got this. So the fourth equation is here, and the second equation is here, and we are adding them up. We are not only adding the left hand side, but we are also adding the right hand side. So we have basically added up 6 and minus 14. Is this okay? So when you perform this function and when you add it up, 12x and x, they are both positive, it will be 13x. 24y plus 7y will be 31y, and then 3z, but then there is a minus 3z, they will cancel out basically. So this cancels out this, and we are left with minus 8. You have to revise whatever you have learned so far in adding and subtracting, multiplying and dividing the numbers, right? So this is something that you will have to practice before trying to attempt these kind of questions, right? Now we are left with basically, this is the equation that we are left with. Now this is equation 5, and now please note that it is only having 2 variables. Now if I somehow find another equation of this sort in which there are only 2 variables x and y, I can make use of these 2 equations then to find the value of x and y, and then based on the values of x and y I can also find out the value of z. Is this fine? So what we are going to do next is, now I have to perform similar kind of function so that we get another equation which does not have a z. And now please have a look, this is z here and this is plus 2z here. If I multiply this with 2, what will happen? The whole equation gets multiplied by 2. Now I am multiplying this by 2. Suppose I am able to do that. And then what do? I subtract one of them from the other. I subtract, let's say, after multiplying the whole equation by 2, this will become 2z, and then if I subtract this equation, 2z minus 2z will cancel out, and then we are again would be left with the two variables x and y. So this is what we are going to do next. So multiplying equation 1 by 2, as I said, to get equation 6. Now we'll be getting equation 6. So basically you have only multiplied equation 1 by 2, and this is what you have got. You have to do this particular mathematical operation on both the sides of the equal sign. So this is what you have got now. Then again, now you have got 2z, and now if you use this particular equation and this particular equation which is here, and subtract one from the other, what will happen? 2z would cancel out 2z, and this is what we are going to do next, subtracting equation 3 from equation 6. So this is equation 6, and on both the sides we'll have to perform this function, right? So this is equation 6, so I have kept it here, and I have to subtract equation 3 from equation 6. So this is equation 3, equation 6. So equation 6 has been mentioned here, and now we have to subtract equation 3. So this was equation 3 minus 2x minus 3y plus 2z. So this is equation 3. This is equation 6. Now we have to subtract not only on the left hand side but on the right hand side. Remember, the operations have to be same on both the sides. So 4 minus this 3, right? Fine. And now we are opening up the bracket. You know, when the sign outside the bracket is minus, what happens to the terms inside? Their sign also changes. So plus becomes minus and minus becomes plus, and this is what I've done here. And now you can have a look here that I've been able to cancel out 2z by 2z, and what I'm left with is 6x plus 19y is equal to 1. Now this is my equation 7. So basically these two equations which I have now found, I now have obtained, they are basically in x and y, and now I have basically two equations which are in x and y, and I've got two variables which I need to find out. So solving the two equations 6 and 7, I'm sorry, we have to solve not equation 6 but equation 5 and 7. Oh, well, this is a mistake I've made. So just a moment, let me correct it. So basically we are solving the fifth equation. Fine. So the fifth equation is going to be used along with the seventh equation. These equations have been marked in red. So you can have a look here, they've been marked in red. Now we have to basically solve for x and y using the fifth and the seventh equations. So basically this is something that we have already discussed in the earlier sessions. You can now easily solve 5 and 7 to find out the value of x and y. And once you find out the value of x and y, what will you do? You can put this value in any of these equations. So let's say in this particular equation, put the value of x and y, and you will get the value of z. So you can find out the value of z also, and then you also have to check. How do you check? So what you have to do now is you have to put in the value of x, y and z in all the three equations and see whether the result that you are getting is equal to the right hand side displayed in these equations. So when you solve after putting the value of x, y and z here, you should be able to get to which is the right hand side here. Then only you can say that your answers are correct. So you have to do this for all the three equations, right, to check your answer. So this is how you check your answer. Is this fine? Now, just to make it clear to you that there are so many ways in which you can do a particular question, this is simply not the only way in which you are going to attempt these questions. I will be just in very brief taking you through a slightly different method wherein we are going to eliminate x. This time we are not going to eliminate z, we are going to eliminate x. So we would be left with y and z, and we'll have two equations in y and z when we'll solve y and z, and then we'll get the value of x using y and z's value. And this is how we are going to proceed in this particular question. Now very quickly I'll be moving, multiplying equation 2 by 4. Why are we doing this? So we are multiplying this equation by 4. The reason is then it will be 4x, and this is also 4x, and if we have to eliminate one, we have to subtract this equation from this or this equation from this. So that is why we are doing this. This is fine. So again, there are slight proofing errors here, I must say. Multiplying equation 2 by 4 to get equation 5. Actually it is equation 4 here. So just let me make this correction here, and then I suppose there would be an error here as well. So I'm making these corrections. So now that we have done this, what have we done in the first place? We had decided to eliminate x. So what we have done, multiplied equation 2 by 4. This is fine. To get equation 4. So this is what we have obtained here. So we have basically multiplied equation 2 by 4. So this has been multiplied by 4. Just a moment, there is some problem here. So we are basically doing what? We are basically multiplying this particular equation by 4, and we are doing it on both the sides of the equal sign. So this basically becomes 4x plus 28y minus 12z is equal to minus 50. So we have done these, we have performed the same operation on both the sides of the square sign. Now you can guess what is going to be the next step. We simply have to use the other equation that we had, this one, and we have to subtract one from the other so that we are able to eliminate 4x. So subtracting equation 1 from equation 4. So what are we going to do? We are going to subtract equation 1 from equation 4. So what is equation 4? This is equation 4. We have to subtract from equation 4 equation 1. So we are doing it for the left hand sides here. Fine. Subtracting sign you can see here. And then we also have to perform the same function on the right hand side. So we are doing it here. From 4 we took minus 56, and then we have to subtract equation 1. So this we have mentioned here, right? So this is what we are going to get. Minus would mean that the signs inside, when we open up the bracket, the signs would change, and that is what has been done here. And then you simply have to do the calculation. 4x minus 4x will become 0, 28 minus 8 would become 20y, and minus 12z and minus z would add up to become minus 13z. Is this fine? And we have already done it on the right hand side. Minus 56 minus 2 has already been shown as minus 58. So this is my third equation which now I have obtained. The fifth equation which I am going to make use to find out the value of y and z. Now can you think of some other way in which we can eliminate x? Yes, if you look at these two equations, can't we multiply this equation by 2? Once we do this, then I can subtract this equation from this, or the other way around, to eliminate x. And this is what we are going to do next, multiplying equation 2 by 2. So basically we are multiplying this equation by 2 this time to get equation 6. So this is what we have got. We have done the operation, we have performed the operation on both the sides. So this is what we have got. Then what we are going to do, we are going to subtract equation 3 from equation 6. This was the equation 6. Now we have to subtract equation 3 so that x cancels out. So this is what we are going to do here. Equation 6 is here, equation 3, the left hand sides we have subtracted. Then as far as the right hand side, we have mentioned it here and then here, right? So this again, when you do the calculation, this would result into this particular equation, 7y minus 8z is equal to minus 31, and this would be your equation 7. And now again we have got two equations which are in two variables, and I can use these two equations to find out the value of these two variables y and z. Once I've got y and z, then I can put these values of y and z in any of the equations here and find out the value of x, and then I'll have to check also, right? How do I check? I'll put in the values of x, y and z in all the three equations and see whether the result is equal to the right hand side or not. So I'll put in the values in the left hand side and see whether the result is equal to right hand side or not. This, since we already done, I'm not going to take it up. I'm also not solving the equations further. You can do it on your own. We have already discussed how to go about solving these questions, right? So I'm not going to discuss this. I hope you would be able to do this on your own. Now the task for you is, first of all, you should understand how to solve the linear equations. We have already discussed it. Go through the video again and again and try your own ways of doing this particular question. And then once you are through with this, then you should practice on some of the linear equations in three variables. Fine. One last thing, we eliminated z in the last instance, and this instance we eliminated x, but we didn't try to eliminate y. Do you know why this is the case? We could have eliminated y, but then it would have been a long drawn procedure. Why? Let's take 8 and minus 7. If we have to eliminate y, then the coefficient should be equal. So how can we do that? We'll have to multiply this equation by 7 and this equation by 8. So this equation by 8 and this equation by 7. Then it would be plus 56 here. It would result into plus 56. And this would result into minus 56. And then we'll add up these two equations, and then we would be able to eliminate y. But then, since it is going to be a little more time consuming, we deliberately took up x and z rather than trying to eliminate y. Fine. So you have to use this common sense while solving these kind of questions. Thank you very much. Very soon we'll have